which actually is very, very fulfilling. So the Future Fertility Trust, that's what our trust fund, our service is called here. And it gives hope to young people. About 4,000 young people between the age of 0 and 17 develop cancer every year. About the same number between 17 and 30 develop cancer. So it's not common, it's quite rare, but it is quite different from adult cancer. So adult cancer is about things wearing out. This is about things that probably, right in utero, didn't quite go right, and then the cells lose control. I haven't been around quite as long as that graph, even though I might have been around a while. But in 1960s, 70s, if you had a leukemia, you had about a 5% chance of living. So 95% of people died within 6 weeks of getting a diagnosis of leukemia. That's why it's called acute leukemia. Now, 95% of people survive. So this is amazing transformation in the survival rate. Children can tolerate vast amounts of chemotherapy. They have lungs, they have livers, they have hearts that haven't been damaged by alcohol, smoking, life. So they get vast amounts of treatment. But the side effects of that is that they have quite high, what we call morbidity, so the side effects from treatment. And anybody who's had any form of chemotherapy will have a reduced time of fertility. It may only be reduced by 5 years, so you might go through your menopause at 45. Well, does that really matter? You can have hormone replacement therapy. But if you go through your menopause when you're before puberty, or when you're in your teenage years, your age, it doesn't feel so good when suddenly you haven't got the same opportunities as everybody else has. Not only have you had childhood cancer, but now you're left with it for the rest of your life. When do you tell somebody when you're starting a relationship that you know something that they might affect the way they feel about you? We all assume that we're fertile, we all assume that we can have a family, but if you know that, you're living a lie. So when you say that to somebody, well, lots of these girls and boys who find themselves in that situation don't go on to have relationships. They don't fulfill the potential. They end up finding life very, very different from the life that we all hope that we're going to have. So, this is just to tell you, again, a little bit about what Molly says, because by knowing the basic science, we can start to do something about it, and that's what we've done here in Oxford. So, when you're 5 weeks in utero, even before anybody really knows you're around, we can tell which cells are going to be your egg cells. By 5 months in utero, so halfway through the pregnancy, you've got between 3 and 7 million immature eggs in the outer cortex of your ovaries. And from that moment onwards, it's downhill. It's downhill until you get to menopause at about the age of 51 in this country, when you've got between 100 and 1,000 eggs left. At your age, at 18, 17, 16, 18, that sort of time, you're losing between 2,000 and 5,000 eggs a month. They start the journey of maturing and then they die. One of those, once you go through puberty, becomes a mature egg. You need 500 mature eggs for all the cycles you'll have between puberty and menopause. We were given many, many more than we need, but the effect that chemotherapy and radiotherapy and treatments have is that they significantly reduce that reserve. So you not only lose large numbers of eggs, thousands, hundreds of thousands of eggs when you have chemotherapy, but you also age your ovary. So when you're 18, every month you try for a pregnancy, you have a 50% chance of a pregnancy. When you get to about 30, it's dropped to somewhere around 20%. So every month you have a 20% chance. When you get to 45, every month you have a 3% chance. So when you bring your menopause forward, effectively what you're doing is aging that ovary. So not only do you have fewer eggs, but the eggs that are there are unlikely to function. Now, you chaps are a different problem. So boys don't produce sperm until there's testosterone around. So in your what are called the Sertoli cells, you have the stem cells to produce sperm, but until you go through puberty, you cannot produce sperm. So for boys, the problem is that if those stem cells get damaged, you will never produce sperm. You may be able to go through puberty because you may have testosterone, but you may not have any sperm cells. So both girls and boys going through treatment are at risk of infertility. Now, this is a young lady who I got to know soon after I moved here in 2007. We'll call her Charlotte. She's an amazing young lady. She was your age. She was quite a sports person. She developed back pain and leg pain. But, you know, she did a lot of sports, so people thought maybe she'd just sort of got herself a sports injury, and she had some physio, but she really didn't make much progress. And eventually somebody thought, oh, maybe we should do an X-ray. And after an X-ray, they thought maybe we should do some more tests. And this young lady has a horrible, horrible tumour of the pelvis. So she was going to have surgery, chemotherapy, and radiotherapy, and she was definitely going to be made infertile. And when I first had this discussion, and we're always, before we start treatment, it's very important for us to be able to talk to people about what their treatment and their side effects are going to be. And you have to be honest and open, because otherwise they don't trust you throughout treatment. So I have to tell her that she's going to be infertile. And Charlotte did not want treatment. She absolutely said she'd rather die than to be left in a situation where she didn't have any hope for the future. And she begged me to try and find a way in which we could do something about it. We couldn't, because in the UK at that time there wasn't any way we could help her. We could send her to Israel, because they did have an amazing program in Israel. She could have gone to Belgium, or she could have gone to Paris. But she was really, really ill, and she needed to start her chemotherapy if she was going to have any chance of living. After much discussion, she did decide to go for treatment, but she could have refused treatment, and that would have been within her right to do so. And it's a very difficult problem when somebody faces you with that. Anyway, as a result of that, as Molly has said, I spent a lot of time on PubMed looking for what I could do. And we discovered that there was this work that had been going on in other centres around the world where you can take ovarian tissue and you can freeze it. And when you want to put it back, this ovarian tissue gets its own blood supply and it behaves just like normal ovarian tissue, and you get your periods back and you start producing eggs. And that was a dream. We thought, we must be able to offer this to people in this country who are in a similar situation. But there are many, many obstacles to go through. If you're going to develop a completely new service that nowhere else is doing, you have to really mount some very big challenges. So let's just think. We have a clinical problem. We've worked out there's a clinical problem. We know there's a scientific solution. We've found that. Now we have to translate that into something we can do here. So the first thing is you have to find some people who are interested. You have to build a team. You have to have all the different players on board. So this project is unique. It's about all different players coming together. We've got the university involved because this is a major, major area of big research. We have all the NHS people here. Some of my colleagues are here today. So Kakila, who does all the paediatric surgery, is here. Anne, who does some of the research work, is here. We work together as a really big team to make this happen. You have to show that it works in animals, because actually nobody's going to let you start taking out ovaries and things until you can show it works. So you have to first of all show it works in animals, then you have to get all the HFEA, HTA, the Human Fertilization and Embryology Authority, the Human Tissue Authority, they all have to agree that you can do this, and you have to have licenses. Your own hospital has to agree that you're able to do this, because it's taking on a huge responsibility. You have to have funding, and that's a really major issue. There's no money, as Molly said. So much of this work is done by people almost out of the goodness of their heart. Well, certainly it's done in excess of their normal working, but it's also funded from charitable funds. So this work here in Oxford we started to collect tissue in 2013, and we've now helped over 150 young people to be in a position where we've preserved their fertility. And that is all done through money which we have raised from charity. Eventually, the NHS will take this on. We have to convince NICE that we have something that works. We have to get all the evidence together to show them, so that's what we're doing, and we're nearly at that point. We have to get NHS England and all the powers to be at that point, from the ministerial level all the way down, to agree that this is something that should be funded. And you might think that's a no-brainer. I mean, you wouldn't chop off somebody's leg, would you, if they had cancer, and not give them a prosthesis so they could walk? But actually, that's not quite where we are yet with the same for fertility. But we're getting there, and we will get there. But on top of that, we have to build a new research. We have to build on this research, because, as Molly said, and as somebody else, various people have said, this tissue may contain malignant disease. Now, the eggs will never contain malignant disease because they were made before you were even born. And the stem cells from the testes won't contain it, but the tissue around it could. So we have to develop ways in which we can either be absolutely certain this tissue doesn't contain metastatic disease, or we have to be in a position where we can actually isolate the egg cells or isolate the stem cells and put those back such that they function. And those large research projects are all going on here in Oxford and around the world. As I say, we've had 180 referrals. We've dealt with well over 150 patients now. We started the prepubertal program in 2015 for boys. So if you're pubertal, you can go off and store sperm, but if you're prepubertal, you have only the choice of storing your tissue. We offer it to patients across England and Wales, Northern Ireland. They come here to Oxford mostly, but occasionally we go and collect tissue from wherever they're having their surgery. Now, as I say, there's a lot of research work going on, and this research here is showing that if we take tissue and we can, in the test tube, we can get that tissue to grow, we can produce eggs that we can then reintroduce back through IVF. And this has been done in mice. We know that it works. What we have to translate that into now is doing it in humans. So this is sort of the work that's going on in the labs. The other work that we're doing with testicular tissue is if you take those sperm stem cells and you isolate those sperm stem cells, you can reintroduce them, just like you can give a blood transfusion. You transfuse these back, and they find their way back into the right part, and then they start functioning again. And this experiment has been done in rats, and they've marked the testicular tissue, isolated the stem cells, injected them back into the mice or rats, and then they can see the progeny actually containing the cells from the stem cells that were put back. It's more complicated you can't just do exactly the same thing in humans, because sadly we're not quite the same, or maybe just as well we're not the same as rats, but it does require us to take some further steps. As I said right at the beginning, this work doesn't happen without amazing amounts of goodwill and teamwork. One of the things you have to develop in medicine is working in teams and making it happen.